Okay, so this is the 5.1 notes, nth roots and rational exponents. So the first thing that we're going to talk about is a little bit of vocabulary, and we're talking about the nth root of a. So when we say the nth root of a, what does that look like? Well, it simply looks like the nth root with the base a. So, and this another way to write that is we have our base a and then the 1 over n exponent. So the index of a radical. So what is the index? We a lot of times here in class refer to that as the root. So the root, the index, they both mean the same thing. So n is the index. All right, so we can see it right above, right there. That's the index, that's the root. It's the same thing. So it'll be, if it's a square, we assume it's a 2. Other than that, it's actually the number. Real nth roots of a. So we're looking at 2 different types right now. So if we look at this as n is an even integer. So what does that mean? That means the square root, it means the 4th root, it means the 6th root, any of those that have that even index. So if a is less than 0, meaning that that number on the inside is less than 0. If it's less than 0, what does that mean? That means it's going to be a negative number. So you're going to have no real nth roots because it's going to yield imaginary numbers. So you would end up with imaginary roots in that. And it's not asking for imaginary roots, it's asking for real roots. Now if a equals 0, looks just like this, it is only going to have one real root, and that real root is going to equal 0. If a is larger than 0, then we have 2 real roots. And why do we have 2 real roots? Well, if you remember, it could give you a positive, it could give you a negative. So we need to make a note to ourselves to make sure, make this a note on there so you don't forget, make sure to do both the plus and the minus, or both the positive and the negative. Now the other situation we might come into is when n is an odd integer. So what does that look like? Well, it could be the 3rd root, it could be the 5th root, it could be the 7th root, and that you can just imagine goes on and on and on, as long as they are odd integers. So when a is less than 0, when a is less than 0, so that would actually be a negative right there, it doesn't make a difference. You're going to have one real root. So you're going to have, right here's our index, there's our base, you're going to have one real root. And as with evens, when a is equal to 0, again you have one real root, and that is going to be equal to 0. Now when a is larger than 0, again you have one real root. So the thing that we should notice here is that when you've got an odd integer, you're going to have one real root. Now when it's even, that's when you're going to come up with different cases. If it's less than 0, we're not going to have any real roots. We'll have no real roots because you'd have an imaginary number. And you're going to end up with 2 real roots if it's greater than 0, because you're going to have that positive and that negative. So moving on down, rational exponents. So it says let a to the 1 over n be the nth root of a, and let m be a positive integer. So what we're looking at is the vocabulary word for this. So the m in this, that is our exponent. And the n in this, that is our index. So those are the correct vocabulary terms, the official language of it, what you'll hear us in class use often is instead of exponent, we'll probably use the word power quite a bit, and instead of index, we'll probably use the word root quite a bit. But they mean the same thing. So you can see here for an example, if we have x to the 3/4 power, we're going to write our root first. So the root, we see that's the one, the index, the root, it's on the bottom of that fraction. So we're going to know that it's the 4th root, okay? And then we're going to, let's go ahead and just put our base in there. And our exponent, that's the top number of that fraction. Well, that's the 3, so we know that this whole thing is going to be to the 3rd power. And what if it's a negative? Well, we learned already that the negative just means that you're going to place it under 1. It's going to move down or up, but right now we're looking at moving down. And we know that we can't have 0 in the denominator. So that puts that restriction on there that a cannot equal 0. So for an example of that, let's just say we do x, and this time we make it to the negative 3/4 as our exponent. Well, what do we have for our root? Well, our root is still the same thing. It's still 4. We still have that same base of x. And our power is still 3. But what it is that negative has now said that this whole thing needs to we need to make sure that we're going underneath 1. So a few examples of what we're working on. Let's see. Find the indicated nth root of a. So we know that if we're just looking at our template here, it's n and it's a. This is our root. So if I do that, I'm going to find the 3rd root of negative 125. Well, I can find this is an odd. 3 is odd, so I know that I can find one that is less than 0. So what I'm looking for now is what number times itself 3 times would give me negative 125. And I know that that is a negative 5 because negative 5 times negative 5 times negative 5 does indeed give me negative 125. That's how I check that. Let's see my next one. Again, what is that format I'm following? The nth of a. So I am looking for the square root of negative 400. Now, you might notice here that I didn't write a little 2 in the corner, and that's because it's assumed. It's assumed with the square root, but only the square root. When you do anything above square root, any higher root, you're going to want to write a number there that tells you what root you're talking about. So I'm going to look at this, and I notice that 2, well, that's even. So if I refer back to my rules, what I remember is that I don't have a real root when this is even. So all we're going to say is that there are no real roots in this situation. Now that's not to say that roots don't exist. That just means that they're not in the real system. So we've already talked about in the past, or I'm sure you've talked about your complex numbers, and how we would find that is that negative 400, we know we would end up with an I, and then we could just look at what is our square root of 400, and our square root of 400 we know is 20. So altogether our answer, if we were not dealing with just the reals, it would be plus or minus 20i. But because we are asked specifically about the real nth root, we have to say none exists, no real n roots, no real roots. Just talking all over the place. Okay, the next one is n equals 6. So I'm looking at the 6th root of 64. So what times itself? That's a positive. Oh, that's wrong. I don't want that. It's not that it's a positive. That is an even, and that's a positive. So I'm good there. That means I'm going to have 2 answers. So my answer is 2 for that, but it's not just 2, it's plus or minus 2. All right. Let's get that there, okay. Evaluate the expression using a calculator. So if you have questions about how to put this in your calculator, I suggest you ask your teacher, YouTube it, look, use your resources to find out how this goes into a calculator. But what we need to address first really quickly is you could, in the calculator, go ahead and put this in as 64 and then your caret, parentheses, 1 divided by 2. That would give you a correct answer. You could recognize that this is the same thing as saying the square root of 64. Either way, it's going to give you the correct answer, which is 8. And here I'm going to look at this and I'm going to see that this is the third root because this is my index. So that means I've got a third root of 27 and the power is 1, so I don't need to write anything on that. So what I'm looking for is it's negative 27. Can I do that? Well, this is odd, so yes, I can do that. So my answer, if you plug it in your calculator, you're going to get negative 3 because negative 3 times itself 3 times will give you negative 27. So here, again, if I'm using my calculator, it can be just plugged in like this, or I can recognize that my index is 5, so I'm looking for the 5th root of 32, but all of that is to the power of 7, or my exponent is 7. So in that case, I think what I would do is I would first simplify what is the 5th root of 32, because that's going to be the easiest part to find. So the 5th root of 32 is 2, but now I still have that power of 7. So I've got 2 to the 7th, and 2 to the 7th is 128. For 49, I'm going to look at this, and I've got a couple things going on here. My root is 2, so I know I'm dealing with the square root of 49, and my power is a 3. But what does this negative mean? What do I have to remember to do in that negative? I have to remember that that all belongs underneath 1. So looking at that, the square root of 49 I know is 7. I still have that power of 3. It still is underneath that 1. So if I were to plug that in my calculator, I would get 1 over 343. Here we've got this is negative. We have an odd index. So yep, we can get a root out of this. So I know that my index, or my root, is 5. Can do my negative 32 in there. But now it all goes to the power of 3. So I think we've already done this one once today. Yes, we have. It's over here at number 6. We know that 32, the 5th root of 32, is 2, but we're dealing with the negative now, so it's negative 2. We still have that power 3. So negative 2 times negative 2 times negative 2 is going to end in a negative 8. All right, here we've got our index, or our root, is 3. So let's start by writing that. And our power is 2, but we've got that negative, so we have to remember to put it under 1. Well, the easiest thing to do first here is to find the third root of 1,000, which very simply is going to be just 10. Now we still have that power of 2, so we'll put that up there. And then the last part of simplifying that is 10 squared. So I've still got my 1 over 100. right, 81. My root is 4. So I've got the fourth root of 81. And my power, or my exponent, whichever way you want to say it, is 3. Well, I'm going to find the fourth root of 81 first because that's going to give me a smaller number to deal with. And I found that that's 3, but I still have that power, so it's 3 to the third. 3 times 3 times 3, going to end with 27. My root is 4, so I've got the fourth root of 625. And it's to the first power, so I don't need to write any power or any exponent there. I can just go ahead and plug into my calculator and find what it is, and that is 5. Okay, second page. It says match the equivalent expressions. So this is kind of a bit of an exercise into what does it look like when it's written as a radical versus when it's written with the exponent. So I know that this indicates a square root. So my root is a 2. It's an understood 2. And my power is that 3. My base is A. So let's see if that matches something over here. And it does. It matches with B. Now let's go ahead and skip down to 14. My root is 2, or I'm sorry, my root is 3. My power is 2. So I've got 2 over 3. I've got my A, and that matches with, did I write that down right? I wrote that down wrong. This is C. That's what that, I think we said the right words and wrote it down wrong. This is B. Now the reason I saved 13 and 15 together is because both of them have negatives. One has a negative out here, and the other one, if we look at our answers that are left, our answers that are left are A and D, and both of them have negatives. So this has a negative out front, and this has a negative in the exponent. So looking at number 13, we see that negative out front. That is the same as it's just a coefficient out front. So I'm still going to look and say, well, I've got a base of 3 and a power of 1, my A, and then I have that negative out front. So that is going to give me D. And here I'm looking and I have that base of 3 and that power of 1, right? So I've got my 1/3 and my A, but it's underneath the 1. So if it's underneath the 1, I know that my exponent is going to actually be what's negative. So if it turned into your fraction under 1, you know that your exponent is what's negative. If the negative sign is out front, then you're dealing with a coefficient. In these exercises, find the real solutions of the equation. Round your answers to 2 decimal places when appropriate. Okay, so that's important. So now we've learned all these things we're going to do, and we're going to put them to practice by finding the solution. So I'm going to remember my order of operations and my opposite operations, my inverse operations, and I want to get that x alone. So the first thing I'm going to do is I notice that I have a 6 multiplied to it. So I'm going to divide both sides by 6. That divides to 1. I don't see it anymore. So I have x to the third equals -1. But I'm not there yet because x isn't alone. This is telling me that it's x to the third. So how do I get rid of that? Well, I need to do the cube root or the third root of both sides to get rid of that. So x equals -1. And that's because -1 times -1 times -1 gives me -1. Number 17, I'm going to do the same thing. I'm going to look for what can I get away from my x first, and I notice that I've got this 2 multiplied by it. So I'm going to divide both sides by 2. which cleans that up a little bit. On my left side, I've got x plus 5 to the 4th power, and this is just going to be 64 over here. Now, if I take the 4th root of both sides, it's not going to come out even and clean. It's going to give me a decimal. So if I plug that into the calculator, my decimal is going to end up being, I've got x plus 5 on the left-hand side still, and on the right-hand side, I've got 2.83 because we're rounding to the 2 decimal places. But it's not just that, it's also, we have to remember this was an even, and it was bigger than 0. We've got plus or minus. That gives us 2 answers. So are we finished yet? Not quite, because we've still got this plus 5 that's stuck to the x over there. So I need to subtract 5 from both sides. And when I do that, x equals my negative 5. I'm going to list that out first because I can't put anything between this plus minus and that 2.83. It's important to remember. So I've got plus or minus 2.83. So to actually finish solving this, I'm going to have to do 2 different problems. I'm going to have to say negative 5 plus 2.83, which gives me approximately, since this is a rounded answer, I'm going to say it gives me approximately negative 2.17. And then I'm also going to say negative 5 minus 2.83, which again is an approximation, negative 7.83. So this was an example of when we had 2 answers because it was even exponent. Down here, I see that I have a negative or a minus 32, so I want to eliminate that by adding 32 to both sides. When I do that, that goes to 0, so I have x to the 5th equals negative 32. Well, I have a negative here. I have a negative, but I can find a real root to that because I'm dealing with an odd exponent over here. So x is going to equal, let's get that 5th root of negative 32. And again, we've done this several times already. That's going to give us negative 2. There's only one answer to this because I was dealing with an odd. All right, first thing I want to do here is let's go ahead and get rid of that 100. I'm going to have negative 1 over 10, 1 divided by 10, times x to the 3rd equals negative 100. And I'm going to get rid of that negative 1/10 by multiplying both sides by negative 10 or 10 over 1. When I do that, I will still have that x to the 3rd, but now it's going to be equal to 1,000. That's just multiplication. I get rid of the 3rd by using the cube root, so the cube root of 1,000 is 10. Nearly finished. We have one more problem, and this one's a little bit more practical. It's asking us to find something that, for whatever reason, we might need to know the dimensions of a cube. So it's asking us to find the volume, they're telling us the volume of the cube is 1,728 cubic inches, and it wants to know what are the dimensions of a cube. So if we think about a cube, we've got our cube right here, and it wants to know what are the dimensions of the cube. So what are the length, the width, the height? We're looking for all of these. And it's easy to find in a cube because they're all the same in a cube. So we're going to look at, well, how do we find this? We know that this times this times this gives us the volume, right? That's how we find the volume. So we know that x cubed equals the volume. Well, it tells us what the volume is. So x cubed is actually 1728 cubic inches. Well, how do we get rid of the cubed now if we're solving for x? We're going to cube root both sides. You can plug that into your handy dandy calculator, and that will give you that 12 is the dimension. But 12 what? We're dealing with our label, we're dealing with inches. So each one of those edges, or each one of those sides, is 12 inches. So those are the dimensions. The dimensions are 12 by 12 by 12. So the length, the width, the height, they're each 12.